Good afternoon. I'm Richard Thron, and this is the Air Rotary class, very obviously. I got some housekeeping. Bathrooms are out the door to the right. If we need to leave the room in an emergency, go out the door to the left and follow the exit signs. There's a critique sheet for the Expo that they'd like you to fill out so we know what to do and how to improve the programs. Any suggestions, ideas you have. There's a lot of directors walking around in the blue jacket or, well, Alan left, in the maroon jackets, and suggest to them ideas and thoughts for future speakers. But we would like you to critique this so we know where we stand and what we can do to improve the programs. Another sheet is signing off for your continuing education credits for your state. Some of you may have a private form for your specific state, and I'd be more glad to sign that at the completion of the class. We appreciate if you would put your phones on vibrate or shut them off. And the other thing that I wanted to share with you is that there is a number for this class. Yes, I do have it. that I will give to you at the completion for your continuing education. You not only have to have the sheet signed off, there's an identification number that you will need for that. So moving right along, we'll get started on this class. I've got a lot of things I want to cover. We had done the mud rotary and the air rotary classes last year, and they asked us to come back to do it again, and I changed mine around to add a few more things to it with suggestions that some of you had. So I appreciate that. I'm Richard Thron. I'm a master groundwater contractor with the National Groundwater Association. I'm president of Mantyla Well Drilling in Lakeland, Minnesota, and presently serving as vice president of the contractor division. I was president of the Minnesota Water Well Association in 1991 and presently serve on the convention and legislative committee, education committees. Also a member of the Wisconsin Water Well Association, the Minnesota Groundwater Association, and I've served since 1991 on our Washington County Groundwater Advisory Task Force. It's very important that you be involved in your local governments to control what they may try to impose on you and direct them in the right direction. Believe me, folks, these guys don't have a clue as to what direction they're headed. And I've been able to steer them. I had a sunset. I got offered for a year. They tried to hire another driller from outside the county, couldn't get anybody to come in and serve. I'm back on the committee. But we have the opportunity to direct our future. And so please, even though you don't think you can do this, you can do it. It's your livelihood. It's your future. And I want to share that with you because I started out years ago, probably couldn't even carry on a conversation by myself, and I was kind of forced into it in the business where my father put me out in front of the customers. And now I can get up and somewhat comfortably give you a presentation because I think I know my stuff to a degree where I'm comfortable in presenting it. So again, let's continue on. This is the air rotary class. This workshop will present general information on air rotary, safety around the drill rig, and selecting proper tool size, and their uses, safe equipment operation will also be addressed in addition to unique properties of this kind of drilling. In this section on air rotary drilling, we will discuss safe setup and teardown, air rotary drill equipment, proper support equipment, bit selection, and proper maintenance of hammers. I want to tell you right now there's going to be a quiz at the end. It's a one-question quiz, and I'm going to see if anybody finds the answer to that. So the outline is rig setup and teardown safely, air rotary drilling methods, selection of proper support equipment and accessories, and selection of bit for maximum production. Proper hammer maintenance is of utmost importance. You take care of it, it'll take care of you. Rig setup and teardown. I'd like to share with you some safety measures, things to consider at the site location prior to setup. Are you at the right address? This happened last year in Minnesota, and I had another class I was at yesterday. They had the same incident where a development, new homes going in, set up and drilled the well on the wrong address. So check your address very closely. Other considerations, always call for utilities locations. Most all states have a one-call system. If they don't, there's a federal number, 811. They only locate public utilities. Most of our problems are private utilities. And I bet everybody would raise their hand. And I see a lot of heads nodding right here. There are companies that will do these locations, or as we did, we got tired of waiting for everyone. We bought our own equipment. Yeah, they're a little expensive. They were like $4,500 a piece, but we got one for the backhoe operation and one for general use. And the unique thing about that is these instruments are probably 10, 12 years old, and occasionally they need some work on them, but they do serve their purpose because the utilities companies locate it within 3 feet. Your obligation is to find it, hand dig it. Yeah, I do that in Minnesota this time of the year. But we can locate with these locators right to the nth degree. We can get right down to where you're right on that marking if you use the time and efforts to do it. And it saves you in a lot of cases. Same with private utilities. My son and I was on a job the other day. We were going to do some backhoe work there. And all of a sudden we realized, whoa, 1, 2, 3, 4, 5 extra conduits coming out of the building. They were all private. Ended up they crisscrossed the well. One of them being a sewer line, one being a gas line, and the rest were electric lines. Wouldn't that made a nice mixture? At any rate, when you do the public utilities, put an expiration date and duration on there. And what you want to consider is the fact of delays due to weather, other subcontractors on the site, materials delays, and of course breakdowns. For the duration, I generally tell our people to put 1 week to drill the well and dig the water line. You can put whatever you want on there, but after a month, I think it's 30 days, you have to get a relocate to upgrade it. Site meetings are extremely important if you have a unique site that has certain properties, such as high pressure lines, high electrical, voltage lines, fiber optics, oh my God, don't go there, and other things. The deal is that if there is a concern, meet with these locators, tell them I'm going to be drilling the well here and I'm digging the line over there. And that way they understand what you're going to do and you understand where they're at. It'll save a lot of headaches in the future. Maps and drawings, a lot of these one-call programs, and ours in Minnesota is on computer now, and it's quite easy. Draw maps to define what you're going to do and where you're going to do it. That way there isn't any doubt or less chance for error. Flag or paint? I say both. And again, I'm in Minnesota. We want to flag it and paint it. One is due to rain, washing away snow, grass growing, and the customer mows the grass. There goes your paint marks. So if they put the flags in there, at least they have to hopefully mow around those flags. But if you do both of them, it's going to give you a better opportunity to understand where the locates are. We go out and draw a site map and try to draw in the different measurements so we can better understand what our goal is here in not damaging any of those utilities. Appropriate blocking methods. Proper site preparation. It may be a site that's got a little more slope to it than you want to put that heavy piece of equipment on. Bring your equipment and your backhoe, your skid loader, whatever in. Prep that site so it's the most safe site that you can have. You get that 50, 60,000 pound rig up there and it gets shaking and rocking and rolling around there, and especially this time of the year in upper Midwest, frost, snow, ice, cause that rig to shift. And I rode a rig down a hill one time and it's no fun. Prep the site properly, blocking of utmost importance, and it all comes back to safety, and safety is for the betterment of your operation of your company and your employees, as well as the bottom line for insurance and safety. You know, when you're dealing with high pressure air, there's so many things that can happen, and we'll discuss a lot of them. Last but not least, always look overhead. We've been on a site, and they turned around and put overhead utilities in while we were gone. Another one that really floors me is we were on a drill site, and they were going to put the gas line in from here to the exit door, basically is the path I would have taken. Because our drill rig was there, they didn't want to wait. They went around our drill rig with the gas line and on over to the street. So observe these drill sites all the time and understand what's going on around you. Good blocking versus bad blocking. Look at these two slides. We'll discuss that in a minute here. Never, I say never, use pallets, cement blocks, scrap lumber, put underneath this $500,000, $750,000 rig to support it. You're going to have problems. We did years ago, and it come back to haunt us. What happened is there was a site that was developed and it's set for many years. We didn't understand that there was a high water table in the area, and they put in several feet of fill. We went in and drilled the starter hole, put the casing in, went to push it down and seat it off, and all of a sudden a massive hole opened up around the left jack. The rig went on over. They, on that site, didn't want the drill cuttings all over, so they left the backfill out of the basement, and in Minnesota the basements are 8 feet deep, so they wanted all the drill cuttings and everything to go down into that area. So the rig not only tipped over horizontally, it went another 8 feet further. There were some costly repairs and some downtime on that. We don't need that to happen. So we, to accommodate that, come up with these 3-inch thick, 12-inch wide, 12 feet long timbers out of white oak. They support the rig real well. Yes, they're heavy. But the fact is we've had several blowouts since then, but no tip overs. Some of these blowouts have been big enough where it takes 2, 3, 4 yards, 5 yards of material, move the rig slowly off-site, re-establish that drill site, and move back in. But we haven't had any problems with that. Another procedure is to consider starter pipes or sleeve pipes in the beginning to prevent this kind of problem. Now let's look at these slides again. Again, I told you about our timbers right here. Now this driller built a bigger pad for his rig, and that's actually about 30 inches in diameter. It looks like it's big enough, but you know what? Look here, guys, gals. It slid back a little bit. Oops. No blocking underneath the rig except for those pads. Look very closely. That blew out from here all the way under these stands right to the back tires, and it's about 5 feet deep. That ruined a good day of drilling. It was quite costly to get that thing back up onto its pads and establish that hole. So again, there is a reason for proper blocking. There we go. Air rotary methods. We want to talk about air rotary drilling. There are resources available, good references. First, check with the local drillers and the manufacturers and suppliers of the different products for rotary drilling that you may be doing. And then NGWA bookstore is another good reference place. We've got the Missouri Water Well Handbook. I use that all the time, and you got the other handbooks that are available. And yes, Groundwater and Wells is the 2nd edition. I have the 3rd edition, but I don't have a current slide. These are all great resources for starting to understand the air rotary drilling method. But again, check with your local drillers and see what they're up to with their kinds of operations, and they've probably experimented considerably and understand this more closely. You ought to understand, to air rotary, what are the formations you're going to drill? Are they soft, medium, hard, crevice, cavernous, all of the above? So then you got to determine what size hole or holes you'll be drilling, and what size drill rod will you be using for your uphole velocity, and what depth will you be drilling to. Then we have to look at what available CFM, cubic feet per minute, or PSI, pounds per square inch, that you have available, or you will need to perform this operation for the best cleaning and penetration. In general, few drillers have too much air. Air density can vary considerably based on sea level versus 5,000 feet in Denver. That compressor can have as much as a 17% loss at the higher elevations. Humidity and temperature also affect this type of operation. So if you have a real hot, humid day, your air compressor isn't going to put out like it should. We've talked about CFM and pressure, and each hammer has a range. So do you need one compressor? Do you need an auxiliary compressor, or do you need this compressor system that one of our local drillers has? Oh, by the way, that was his rig in the previous slide that had the blowout on it. You wonder why? These are 1,200 CFM, 350 PSI compressors that he runs constantly together. I don't know why or how, but I don't ask. But they can create problems, as we discussed. Our rigs have 850, 350, and that basically fills in the range of what our hammers are required for a specific range of operation. Each hammer has a low and a high point that you can operate in, and you got to pick something in between for optimum operation. So you have to know that. Anybody have any ideas on some of the safety factors that you would have with high pressure air? Let's cover a few of them. Maintenance and safety is of utmost importance. Keep the maintenance and up to snup and safety will come into play. Safety relief valves at the proper setting, not like your mud pump blow-off valves where you're putting those finishing nails in. Keep them at the right setting because you're talking with 350 psi of air pressure, and we'll talk a little more about that. We talk about blowdown valves. This is a relief valve, so when you're done drilling with a rod, you take and open up this blowdown valve, and you can relieve the pressure, most of the pressure on the drill stem prior to adding another rod. This picture here shows a hose with some bulges in the casing. I think you can see them from the back, but this happened quite quickly. It was an older hose, but it was a hot summer day, and all of a sudden it started showing bulges in it. That's ply separation. That means that you're going to have problems with a blowout sooner or later, or that thing blowing apart, and certainly don't need that. So understand the hose ratings to come in play with the safety when you're purchasing new hoses. You put in a fudge factor in there for temperature and pressure. Select the proper fittings. You're talking with 350 psi of air pressure. You don't want to be using a standard fitting on that. So if you do any replacement plumbing or additional plumbing to that rig, make sure you have the proper rated fittings. Hose securement is of utmost importance, and most of the manufacturers of the equipment nowadays are putting lanyards on there so that they're secured, and that way if they unscrew or they blow off, generally it happens at the joint, they'll be secured. Now if you can't do that, here's that old hose that has a compression fitting on there. You put a longer bolt in there, a short piece of chain secured down with a lock washer and a self-locking nut on that, and then on the back of your compressor you can put a short lanyard chain on it to hold it on, so if it unscrews or blows off, it's not going to hurt someone. This happened on one of the drillers up in Hastings, Minnesota, and one of the drillers, a big dude, and that hose came off up above, come down and hit him, and it took him to his knees. And he's here to live about it, but that could have been really a dangerous situation there, having a hose blow off at 300 psi. Importance of proper bit selection. Look at the formations on that rock formation in Hudson, Wisconsin. You've got every variety of garbage there that you could ever dream of with all these varied conditions. So when you make a bit selection, you're going to have to determine what possible formations you may be drilling in and make that. If you're going to use a mill-tooth bit, generally, if you're getting into a cobbled mess like this, I recommend a short tooth, which is a hard pattern bit, so you can accommodate all the different drilling techniques. And again, if you're getting into a softer formation, you can get the longer bit for better penetration. If you're going to use carbide button bits like the blue one up on top, then you can select those for the formation you're going to drill in. The one on the right is a short pattern for hard formations. This is a medium pattern with medium buttons, and this is a big button pattern here for the softer formations. So check around, figure out what you're going to need, and go forward with that. The other thing that we use and comes in quite handy is on the mud rotary, they blow out the retipped or used bits in the center for better fluid. And this holds true with the air compressor air rotary method. It allows more air, volume, and pressure to go through there for a cleaner surface on the drilling bit. Therefore, the penetration and production are a lot faster. Anybody using the PDC bits? Okay. They work pretty good? Like anything else, some formations they work good, others they don't. Okay. Downhole air hammers. When considering the method of drilling, several questions need to be considered, as we just covered: the formations, the drill rod size, the hammer selection, and things of that nature. Bit selection is very important as well. Again, we talked about the different sizes, and then experiment. Talk with your local reps as to what the other drillers are using in the area, understand the formations you're going to drill in, and then experiment. Some hammer and bit manufacturers come to us drillers occasionally with a bit or a hammer that they want to experiment with. Let them do that. I mean, what the heck, it might take you a little downtime, but it gives you a free hammer and a free bit for a while. They don't always work. We had a bit that was supplied to us and a new style hammer, and our formations, as you saw them earlier, are a hodgepodge of everything. And that bit shanked on us. They brought us another bit, it shanked. They knew our history of our company not having shanked many bits over the years. They went back and checked that out, and it was designed for a softer, consistent formation, not ones with soft and hard formations and crevices in it. And so they removed that hammer and bit combination from our region, and they use it elsewhere very, very well. Bit size and hardness is very important in bit selection, as we talked about. We generally use a flat bit, like that black one down in the corner down there, for small diameter holes. It's flat and it penetrates quite well, and it works real good. Another reason we would use that in an area where we didn't want to use a stabilizer, we can run that flat bit like that and run a pilot hole down, whether it's checking for nitrates or VOCs or whatever. We can get the water sample or determine where that aquifer is and if the formation is stable enough to put the casing in and complete the well. Run that down. It can run down 200, 300, 400 feet, whatever, and then you're ready to open the hole. There's a concave bit there that we use in larger diameter formations. The concave runs it straighter in the buried formations. But then we open it up with what we call a hole opener. Have you guys used hole openers in the past? Okay. It has a shank on it right here. There's a guide shank that goes in that 6-inch hole, and then this is designed for 6 by 8, 6 by 10, 6 by 12, whatever you desire to open that hole up to. And they work quite well, and it speeds up the operation in developing a hole of that size. Stabilizers. This is the one we would not want to use in air rotary drilling in bedrock. This fluted size here would knock a lot of chunks loose. You would either use a barrel tube type or a spiral type stabilizer. And I'll show you another alternative to that later on. But again, stabilizers are used quite often in the bedrock to keep the hole straight, because there can be crevices at different angles that will cause the hole to wander. And again, you'll have to experiment with it and see what works best. If you do use these different stabilizers, you may want to consider putting some drill out lugs on the top of that. And that reason is that in the drilling operation, you may knock material loose, fall down on the stabilizer and the tool stem as you're trying to get it out. With those little lugs on there, you can back drill your way back out and regrind it backwards. And we've used that in several occasions over the years that saved us on recovering those tools and maintaining that hole. Let's talk about rotation speed. I just skipped over that for a reason. Rotation speed is extremely important. Of course, tricone, you want to run faster for better penetration. And the rotation speed is controlled by the rig that you have. If you have a table drive, as Roger was talking about in the other class, that has more options for speed selections for the tricone operation. But when you come to the hammer operation, you want to slow that down. Okay, let's go over to the top head spindle drives. You're pretty much controlled by the speed of the orbital motors on the top head drive. And generally, when you buy the rig, you make a selection of orbital speed drive motor speeds. That was really unique. You design the top head for the orbital speed that you want, the spindle speed. And so if you're going to do a lot of rock drilling, you try to decide what speed you want based on your hammer's reps, specifications, or suggestions. But again, it makes a difference whether it's a table drive or top head drive. Saber sub, I'm looking at one right now. How many use Saber subs? Good. That Saber sub is just a short sub with a female-male piece on it to go on the end of the spindle of your top head drive or on the end of the Kelly to protect the threads. Sometimes you drop it down a little bit, or you go to make it up and you hear the squealing, and it wears and tears. And why tear up a spindle, which is quite expensive, or tear up a Kelly that's equally as expensive, when you can, for a couple $100, buy one of these Saber subs and screw that on and let the wear and tear happen on that unit. Now let's step back a minute to shock subs. How many are using shock subs? They're expensive. There's different designs out there, but they take the shock of the hammer away from your top head, whether it's the table drive or if it's the rotary hydraulic drives. And they're quite expensive, but they do take away that impact that's happening, that jarring that's going on from the hammer operation. Now, on our Gardner Denver rig, we had some issues with the bearings going out all the time. I bet you it was every year we were replacing the bearings on it. Finally, I said to my bearing manufacturer, or my bearing supplier, I says, there's got to be a different way of doing this. And when he checked it out, he had found out that they have extreme duty bearing available. It was a sealed bearing, and I put those in there, and we got a lot more wear and tear out of that, so I wasn't down all the time replacing the bearings. And I'm telling you, like I said, at least every year we were replacing those, and we got quite a bit of time out of it that way. Okay, we've talked about the saver subs and the shock subs, and it's just suggestions. Pull down and hold back pressure. Pull down is usually used in the start of the hole because you don't have enough weight on the drill stem to get the proper weight on the hammer or the bit for best penetration rate. And so you would use pull down on that, pulling hydraulic pressure down on it, or on the Kelly drive your feed to keep a modest pressure on there for best penetration. Hold back pressure is used as you start getting down several hundred feet and you keep adding each one of those 400-pound rods on there. Now you get too much pressure on there, and it's going to cause excessive wear and possible breakage on your drill stem and your tools. So you have the hold back pressure to hold that to the maximum weight that would give best penetration for you. We had a gentleman that borrowed our hammer for a table drive rig. And I tried to explain to him the importance of slower speeds and lesser pull downs and listen to the hammer making a good rat-a-tat to it. And he, probably like me, hard of hearing, went out there and he put that thing in high gear and put all the pull down he could on that thing, and there was a muffled sound on the hammer, which became a squeal not too much later. He ruined a good bit, but he learned that there's importance to slowing the speed down and taking all that pressure off of that. They paid for the bit, and it was a good lesson learned by all. And I still rent up my hammer to them once in a while. But it's important that you understand the difference between mud rotary drilling, tricone drilling, and air hammer drilling. So I just wanted to share that with you. Downhole air pressure gauges. A lot of the rigs are coming out with them now, but in years past, we would put them on our Gardner Denver and our Shrams and all the other rigs. We put those on there so we could understand what's going on downhole. We, up in the upper Midwest, Wisconsin, Minnesota, have a lot of bedrock where there's a lot of crevices, and we've got drillers up there that will not drill. They lose their circulation, they're out of there. This last summer we had one, they went down, I believe it was 90 feet. Jeff was at 90 feet, something like that. And his mud went down the hole, he was on the top of the bedrock, pulled the rig off and hired us to drill the well. By having a downhole air pressure gauge on there, you can understand what's going on downhole. We monitor that air pressure, and the driller can see what's going on with the air pressure and his foam and where the pressure is maintaining at. If it gets in the range of 190 to 250, we start wondering, have we got a problem with our piston or our hammer wearing? We'll put a new piston in there and try that out. And a lot of times I will return our air pressure back up to 250 or a little better. And that's based on your foam thickness and how you're injecting it at what gallon per minute. But that will return that. And if it doesn't, then we pull that hammer out of operation on the main drilling portion of it and use it as a driver hammer. And we'll explain that a little more in the program. But same goes for the bit. If the bit gets worn or has some broken buttons on it, the gauge buttons are gone or whatever, pull that puppy out of there. And then we buy a specific cross pattern bit on the smaller diameter ones, and I'll explain that a little more here later on. But pull that out of there and put a good bit on there for best penetration, because you're saving fuel and labor and everything else. And use that old bit as a driver bit. Again, you can use that downhole pressure gauge for another purpose too. When you're completed with your drilling and you've done your development and you're all done with that job, you can set that hammer near the bottom of the hole or your drill rods with a tricone bit on it and let that pressure equalize. And if I ended up with 43 pounds of air pressure on that gauge, about how much water would I have in the hole? 100 feet? So you can use that way too, so you don't have to carry a water level tester. And of course, the install crew should always run the water level tester down and make sure that where you say the pump setting should be is accurate. We talked about a blowdown valve. This one here is supplied with the rig, in this case here, but years ago we didn't have them. So what we did is we plumbed in a blowdown valve. We put a Marpac valve in with the heavy fittings, and we discharged the 2-inch pipe in the center of the rig down below. So when we get done with the drilling of that, we give it a little more time with the foam to clean the bottom of the hole, and then we would shut the air down, pull the discharge valve, the blowdown valve as we call it here, relieving that pressure, but be aware that there still can be some back pressures there. Okay, I want to cover some PPE, and in doing that I want to share some decibels with you, and this is really shocking. I found this chart. Where does OSHA's regulations begin? 85 decibels. That means if you go out and mow your grass with your lawnmower, you're exceeding OSHA's limits. That's 90 decibels. If you're around a jackhammer or a helicopter, risk of hearing loss in 1 hour with 105 decibels. I'm a snowmobiler, got hearing aids. Risk of hearing damage in 30 minutes at 110 decibels. Baby crying, heard one out in the hall. Stadium football games, in 15 minutes there's hearing damage available at 115 decibels. Rock concerts and sandblasting, risk of hearing damage 7.5 minutes at 120 decibels. Gunshots and jet engines at takeoff, immediate danger to hearing at 140 decibels. Let's get into some PPE. Of course, we were just talking about taking those rods apart and the potential for debris falling out or blowing out of those rods. You want to use good hearing or good eye protection, and make sure it's ANSI approved so that you don't have any shattering of some cheap lenses that are going to cause eye damage. And a lot of times our guys will wear the sunglasses designed because you're out in the bright sun and what have you. And so they're real cheap to buy, and keep some extra ones in the truck there so nobody don't get hurt. Safety glasses can be bought and worn by those that wear glasses. And gloves are of utmost importance. You're drilling in the summer, those drill rods can get extremely hot with the temperatures coming through from the compressor. And of course in the winter it's going to be cold, so you want hand protection there. You got to be careful with the drill rods. They can get little scuffs on them from the breakouts, and that can cause some cuts on your hand too. And why not wear the gloves and protect yourself the best way you can? Hearing protection, there's several ways of doing that. They can be as simple as the inner plugs right here. They can be the helmet mounted ones, and I got one of my guys that don't like the weight of the helmet, so he puts this on behind his head, has a strap back there, which would drive me crazy. And then I had an employee years ago that worked for me that he had, like my hearing aids, molded to match his ears. And he said he really liked those. They were more comfortable than stuff on those styrofoam ones in his ear. So there's a lot of varieties there, and even a couple of our people have put the inner ones as well as the outer ones on because of the long-term exposure with that noise of the air compressors and the operation of the drill rig. Who has more exposure to the noise levels on your rig, the operator or the helper? The helper. Correct. We were involved in a NIOSH study years ago, and they put up this perimeter all around the rig, and it was the helper because he's walking around the rig to all the different exposures of the hydraulic pump noises and the air compressor noises, and the repercussions off of the house on that specific job site, the noise of the air compressor going up and hitting the wall of the home and coming back. It was extremely interesting on that study, but it was fun to understand that too. How many are doing a pre-employment hearing test for a baseline? It's a good thing to do because it'll give you something to go from. And how many do an annual hearing test? You should do an annual hearing test all the time so you have a baseline and an annual program to understand where the hearing's going. One of our drillers a few years ago all of a sudden failed this thing just terribly. So she says, you know what, I'm going to send you to the doctor. So she sent him to the doctor, and here what happened? He had an earwax build up in his ear. They cleaned the earwax out of his ears, his baseline, or his hearing was right back to his baseline. So other things can affect your hearing. Could be that you've got a cold, or it could be that you have allergies. A lot of us have issues that way. So do that. NIOSH had a disc here a while back that you could put on your computer and do your own in-house hearing test. But I don't suggest that. It would be okay, but get a professional to do it. So if you ever have any issues with an employee down the road, you've got documentation. The key to success today is documentation of everything. That will keep you out of the most trouble in all cases. Let's continue on. Most common methods are air rotary drilling. Of course, there's air drilling, which is typical of quarry and mine drilling, and some well drilling. It's very noisy, it's very dusty, it's very tough on the rig, it's tough on the employees, it's tough on the air filters, and it's costly because all this comes into play with the abrasion that is created by the upwell velocity of just straight air drilling and the particulates that come up. But keep in mind that too much air in a borehole can be a problem as well, as you saw that rig collapse there. But as you get into soft zones with too much air, you may be bellying out or causing blowouts in the drill hole, which requires more upwell velocity, more air, and it can create some caving situations that come back to haunt you. And it's more costly to run that air compressor wide open to keep that hole until you get the casing in it. And it also slows down the production rate on it. As a rule of thumb, with just straight air drilling, based on your diameter of your hole and your drill rod, you'll need 3,000 to 5,000 feet of upwell velocity to maintain proper cleaning of the hole. That would be about 6 to 7 seconds per 100 feet of depth on that hole. This can, again, vary by the size of the cuttings. And dust, of course, raises much faster. But you get something the size of quarters, and it's going to take a lot of air and a little more time for that to come up. So when you get to the bottom of the hole with the hammer, you're going to have a little cleaning time to clean the face of that bit off so you don't have cave-ins or fill-in is another word. You got to use caution with this kind of drilling. That cutting or that particulate basically comes up out of that hole at about 34 to 58 miles an hour. Now, I don't know if anybody's been hit with a chunk coming out of the hole like that. I did years ago when we first started our air rotary drilling. We developed a boot to go around the back of that truck, and that's being used by a manufacturer right now, that boot that we developed to keep those particulates from flying up and hitting us. It's not a pretty thing to be hit like that, and it hurt. I saw stars. So anything you can do to protect yourself, do it by all means. Air foam drilling. This method is used when you inject air and foam into the stream, but keep in mind this foam is required to be NSF approved by your state codes. Hopefully you've got a state code for a sanitary water well. Some of it's enhanced with alcohol. Up in the upper Midwest this time of the year, we have to have alcohol in there. This helps for dissipation and preventing of freezing. Caution, alcohol, fire hazard. Alcohol, explosion. We had completed about a 200-foot, 8-inch diameter well, and they were going to weld in the 4-inch casing. The driller got the casing set on the table there, and he bent over and he was starting to weld the shoe on. And he heard this whoop, 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 whoop. So he stepped back with the helmet still on his face. It blew a shot of flame out of there like there was no tomorrow. What happened is there was alcohol that stayed in the borehole, and when the sparks hit it, they had a downdraft day where it was sucking air down that creviced hole. And when those sparks got down to that alcohol, it created an explosion. And fortunately, had a little singed hair, but he was okay on that. So be very cautious when you use the alcohol-enhanced foams. And anything you can do to prevent any accidents is, of course, of utmost importance. Don't be afraid to experiment with these. On some 300 to 500-foot holes, we'll use 12 to 20 gallon of foam in that borehole. And what happens is that will be a little costly, but when you get that hole done in a day or less, that's a win-win situation. Less wear and tear on the equipment. Employees probably don't like it because they don't get as many hours in, but the deal is it saves all the way around on tool wear, and our cuttings usually are like shaving cream coming out of the hole, and it lifts more cuttings, and the foam forms a uniform bubble, and that's how it gets its lifting capacity. And so in a nutshell, foams have a lot of advantages, such as the upwell velocity requirements are less, and it has a higher solids carrying capacity, ability to lift a bigger volume of water, reduction in erosion of the poorly consolidated formation. It reduces the air requirements, effective dust suppression, increased borehole stability, and it's less costly. Air mist drilling, that's the same as air foam drilling, only it's in lesser quantities, and sometimes you want to use that based on a formation you're going to be drilling in. Air foam gel drilling. Has anybody done that? Okay, I bet you would. We got a representative in the back of the room. At any rate, what that amounts to is if you run into a well where you're going to have some lenses of sand, or you encounter lenses of sand, you can mix gel and bentonite together, but check with the manufacturers as to what recipe to start with on that, and then experiment with it. Of course, the trichome bit's going to be more forgiving because of the larger holes to allow it to pass through, and the hammer needs it precisely mixed so that it can pass through there without plugging it. And the thing is get that hole drilled, get your equipment out of there, and get that casing in as quick as possible. It saves on installing an outer pipe. And the thing that you want to keep in mind is that hammer needs to be cleaned. I mean thoroughly cleaned. And then put some oil in there so that it is lubricated. Otherwise, that bentonite is going to cause some major rusting. You can try that method. Again, it's going to take experimentation. I just talked about pouring some oil in there. Rock drill oil is a specific oil that's environmentally safe, and it lubricates the hammer during operation. But when I first got into this, I said, oh, rock drill oil, I heard about that. So where am I going to get this stuff? So I talked to my local supplier, and he said, oh, yeah, Texaco Aries ISO 100 rock drill oil. He knew really what I was talking about. So you get a 55-gallon drum, and when this gets low, I just order another one. But this helps lubricate the hammer to prevent rusting and better operation. When we run the heavier foam, we don't run the oil injection. When you're running foam like shaving cream, that gives plenty of cooling and lubricating properties to keep it going. Proper containment of drill cuttings. It's an issue for everyone. The first two slides on the left, of course, are very obvious. There's room for that stuff to run. Everybody's getting more concerned about this stuff, and you better have your MSDS sheets on board so when someone comes up and says, what are you drilling or what do you got, you can show them what they are. The slide on the right, you see that little spot there that kind of goes down the yard and over there? We're on the top of a hill. Folks, there was no place for anything to go. It went downhill. When we got done drilling, we went down and we shoveled all that foam off the top of the snow. And of course, you know what happens when you tromp the grass down or you remove the snow, it froze the ground. But in the spring, the homeowner came to us and said, okay, you got to fix my yard. Okay, fine. Well, we went out there and I took this picture. Doesn't that look awful fresh, guys? He had new utilities put in because the gophers got down and ate the gas line off and they put a new one in. He wanted me to pay for the whole yard. I said, whoa, time out. I'll help you, but I'm not going to pay for the whole thing. Documentation. These doggone things, I hate them, but I tell you what, take all the pictures you can. This will save your little tush every time. And we take pictures on almost every job, and we're putting them in the customer files to protect you. Containment bags are becoming real popular in certain areas, and I know Roger Renner's had to use them. For air rotary and mud rotary, you're to use containment bags. We're kind of skirting the issue a little bit in some areas. Other areas you can't get away from it. I've used vac trucks to vacuum up our materials, and we use silt fences all the time to try to prevent stuff like this. But again, in some cases you can't get away from it. But containment bags in Minnesota are to be used to collect these cuttings. And the MPCA said that we're supposed to dispose of them in the proper manner. And we said, okay, what do we do with them? Dispose of them in the proper manner. They don't know what to do with them. So that's an issue where we're going to have to try to train some of these people as to what stupidness or no common sense is being put into these programs. And that's why we need to, you need to, I need to get out there and address these issues to control what's going on. Because sometimes there's no solution. They make the law and there's no solution to it. Proper containment, again, can be a real issue. Let's talk about hammer maintenance. Know your hammer and its parts. Know how to recognize the wear. And I talked about the 190 psi on our hammers, and we understand how much foam we're putting down there or how much air we're putting down there to recognize the wear on that hammer. And the importance of proper lubrications, whether it's the foam and the drill oil or one or the other. And hammer storage techniques are extremely important. Hammer care, understand the consumables, and carry some of them with you. You got the dart valve, the O-ring, the blow tubes that may be on some of the hammers, and of course there's a piston right there. And we carry a lot of that stuff on our drill rig, so if we see a problem, we tear it down and fix it right away. And then of course here's the hammer care. We, again, blew this hole into this formation, got it out of the hole, and put the casing in as quick as possible. Then we turned around and cleaned the hammer up for proper storage. Always store the hammer standing up. Clean the hammer out, pour a little drill oil in it, and stand it up. On our drill rig, the hammer is stored in a 12-inch piece of pipe. That way 6, 8, 10, and 12-inch bits can fit right in there. We've got a containment chain on it, and of course it's capped on top. Then of course the little hammer in the shop is stored up against the wall, chained down in the big hammer. That guy is about 6'3", so you can understand how long that is. Remember we talked about stabilizers, and I told you we were going to show you something that we did in place of a stabilizer? This is a 8-inch hammer, 8, 10, and 12-inch hammer, 4.5-inch box on it. Our hammer rods are 3.5-inch. To put a short sub in there would put a lot of strain in that part of the system. So to reduce that, I went to a machine shop, and he made me this 5-foot-long solid steel rod with a 2-inch hole bored through it, with a 4.5-inch pin here and a 3.5-inch box. It's amazing how rigid that is and how that keeps that hole straight. And in a lot of cases, based on the size of the hole and the formations we're going to drill through, we don't put a stabilizer on. So it saves us carrying extra weight out to the job site and extra things. But it's things like that that you can turn around and develop on your own. And the other thing is we put some slots on it so that the fork would fit in it for tear down and makeup on it. But again, store the hammers in an upright position. Make sure they're clean. And same way on the hammer transport. We've got these hammers in the back of the tanker there. And we got the plugs in them. And we got called in on the scale for not having it secured. That's nothing more than a dog chain. Last 5 years they haven't argued with us. It's something that secures it. They told me I had to have that securement chain on there. He's a rookie. And his boss laughed at him. But he says, you know, in case you hit a bump, that could bounce out of there. And I said, sir, I says, with a tri-axle truck at 50-some thousand pounds, if I hit a bump hard enough to pop those hammers out of there, I don't want to be in that truck. And his boss laughed at him. But he says it needs to be secured. And I said, fine, no problem. And then on load securement, we'll talk about that in a minute. But if you take care of these hammers, they'll take care of you. It doesn't take a lot to blow them clean, flush them out, put a little oil in them, put a cap on them, and secure them properly. We're going to talk about some things I was asked to add to the program. And what they are, we'll go through them quickly, is basic maintenance. This is a type of elevator for plain end pipe here. It's got a latch, it's got a spring, it's got a puck, it's got a jaw in it. Keep it clean, keep it lubricated, and make sure it's not worn and it's in proper adjustment. You don't need that 20-foot piece of pipe coming down and hitting you. I don't know any man around here that can handle a piece of 4-inch, 6-inch pipe on top of their helmet. And if one of you say you can do it, I'm out of here. Oh, back up. I want to show you one other thing. In that corner down here is it's hard to see. I'll tell you what, I got another picture here. There, up there, right here is a basic screw-in plug with a swivel on it, and we put some 7/16 rod on there so you can turn it better with wet hands. But that can get worn, it can get bent, it can get cracked. Inspect all this stuff all the time to make sure that you're not going to have a problem with it. There's another item right here. This is what we use on 6-inch plain end that we developed to elevate the casing and use the hammer to screw it together and drive the casing. How that works is it's a little bit hard to see, but there's a limiter ring right there that limits the amount of threads that can be threaded into that coupling so you can unscrew it. And another look at it, here's the 3/4 inch wide plate, about 2 inches, 2.5 inches thick, that the hammer sets in on. A 6-inch hammer with a cross pattern sits right in there, and you can screw it together, and it's an old dummy bit anyway with no buttons on it, and you can drive that casing on down to seat it off. We make driver plates to go in the 4-inch and 6-inch casing. We buy stock at a local supply house, and we put it in the lathe, and we turn it down so that there's an adapter that goes in 4-inch plain end and threaded, and 6-inch plain end and threaded, all in one unit. And then it has an indent on the top where the hammer sets in so it don't scuff off or don't kick it out. And it really helps us in sealing off the casings. To get that driver plate in place, sometimes it's up 3.5 feet or so. You know what the regulations are, guys. So it's up a few feet off the table. We've built this basket here, and you can see this little plate here. It kind of cocks it backwards, and then these are more towards the front. So it's a cocked situation. So you take that up to the point, and then you push that driver plate onto the casing and can drive the casing. And it's up to you to decide how and what you want to do with it, but it's just some suggestions. The other thing is guide slips on the table on the drill rigs become worn over time. The drill rods get worn, and you get that blow-by, and it's a pain in the patoot. What we found is that once they wore to a point after the rig was a few years old, we took them to the machine shop. We found this nominal pipe available at a supply house, and what we did is we had them machine this out right here to accept the outside diameter of it, cut the length we want, and then we cut it and split it in half. Install those in there, weld them in with stainless steel rod, and use them until they wear out. Then you just grind the weld off, and you take another one, cut another piece, split it, put it on there, and weld it on. It gives a very tight fit on those drill rods, because if your drill rods are doing this on top, what's it doing on the bottom, and what's your hole going to be like? So the straighter you keep the hole, the more production you can make, and this is just an idea that we use, and it works quite successful for us. Your donuts, as they call them, that are underneath the table to prevent debris from blowing up. We found a little trick that by the small diameter, the 2 7/8 rod size, use them till they start blowing by. We've got a cutter. It's a belt cutter. And what we do then is we cut it to the 4.5-inch rod. You get double wear out of it. Nah, that's not good enough. Let's go for triple wear. What you can do is you can then, like on our 8x4 wells, you can take that donut that's starting to leak on the rig and put it on top of the 4-inch casing over the 8-inch casing and prevent the debris from going down on your final drill out. And if you don't have that on your rig, you can take some just regular conveyor belting we get from the local gravel pit, and we cut a hole in it for the size diameter of casing we'll be using, and there's a little split right there, and you put that over the 2 casings. Then what you do is you shovel a little material on it so that the cuttings will wash away and not go down the borehole and prevent you from getting a good grout job. Minnesota gets a little cool up there occasionally. It's a mindset, folks. So this is my old tank. I got to get some pictures of the new one. This is a 2,500-gallon tank in our shop that's about 7 feet off. They back the tankers in, and they use this pipe right here, and it goes down in, and they download. But what's unique about that is I got a 60,000 BTU gas furnace in there, hooked up to a 100-foot roll of 1-inch K copper, closed-looped, spiraled through that tank back into that furnace. I have a Roberts-Hamilton ball valve for filling that tank automatically like a toilet. And then this furnace kicks in, and in the beginning of the season, we put it up about 90 degrees. And as it gets colder and colder into the winter, we go up to about 140 degrees. You don't want to go any hotter than that because it gets so much steam you can't see anything. And oh my God, does that make beautiful bentonite. Carl Mason was up in our area at one time helping us out with some stuff, and we mixed up that bentonite, and he says, I have never seen bentonite so creamy in all my life. It mixed real well. And again, the guys are standing there on the side of the truck, and the customers are looking at those guys with their bare hands, and wow, those guys are tough. The water's 140 degrees, they're warming their hands. But it's a real simple operation. If you're in a cold area, it doesn't take a lot to build it. Build the tank, a little 60,000 BTU, and it works great, guys. I mean, it really works great. Okay, when it comes to breaking out the bits and holding the bits, again, we have where you take out the guide slips or leave them in place, actually, and you can put these plates in there on some bits. This holds the bit in place, and in some cases you can even not put a retainer in the middle because the bit has certain slugs or certain flutes that only go so far, so it would hold on that bit. And this one here, we had to put that rod in the bottom so it wouldn't fall through. But this will hold the bit while you're using your drill rig and your breakout wrenches to tear that down. Then you can take it out of there, set it on the ground, clean it up properly, lubricate it, and store it. Containment. You've got to be able to secure things properly. And I have DOT doing the training of their rookies in front of my shop. I have Minnesota Spinus scale, half a mile up the hill. I have Wisconsin scale, 2 miles down the road. I do my exercises every morning, people. And I've been to court 4 times and I beat them because I know the rules and regulations. So you need to know that for your DOT operation. Keep everything in order and know your regulations. But to keep them at bay, we have what they call a Good Faith Act in Minnesota. And what happens is that the more you can present up front, the less trouble you're going to get into. So what we did is we have them shrink wrap our pallets of cement. We use our straps, and I even have an aluminum plate that goes over the top. So if there's any shifting of the load, in this case here, it's shifted towards the front. But the fact is, they see that and they love that. So anything you can do in your load securement to keep them off your back, do a little extra work and it'll come back to pay you. Completion of the well. Be sure and properly seat that casing for the best well you can. Needs to be properly grouted to protect it from contamination. Proper development to make it the best well ever. I was just on a well recently, and it just wasn't doing anything. We went in and redeveloped it with our air compressor, and I made it 3 times the well it was. It was down about 3 gallons a minute, and we got it up to about 25 gallons a minute. By just going into the air compressor and redeveloping and blowing the cuttings out of there, what the technique was of that driller, he would come in and drill the well, and he used water. He pumped water down the well. He wouldn't blow the debris out of the well. So he was actually plugging the aquifer. So we went in and we blew it out with the air compressor and scrubbed it and made a heck of a well out of it. And it, you know, you properly developed, make the best well that you can, and wellhead securement. By all means, put a vermin-proof cap on it. In some cases, you might want to put a post up in front of it. When we get on a job site where there's a lot of construction traffic, we'll put a post up and paint it blaze orange, hang a flag or yellow ribbons or something on it so they know where it's at. I can't tell you, and I'm sure you can tell me the number of wells that have been run over. It's not a pretty picture. So, what I say is the bitter disappointment from poor quality outlives the temporary joy of a cheap price. We have plenty of competitors, but no competition. Make your company stand out as the professionals. I'm a master groundwater contractor, and everybody asks me, well, what does that do for you? And over the years, it's helped in a degree. They look at that title. But most recently, in the last couple of years, and this summer, I've had customers call up and they got on the NGWA website, saw that I was a master groundwater contractor, and I got those jobs because they saw that I was certified through National. And so those certifications do come into play. And if you get those certifications, the pump installers or whatever, the well drilling or the master or whatever it is, put that logo on your business card. I've got them on my business cards, and be proud of what you are and what you do. And this comes into play. You know, there's a lot of guys out there doing this job. Make yourself one better. Do that little extra step with the customers, and it'll come back to pay you. Safety one more time. Safety training. There's a lot of training available, and you should be doing the tailgate talks. Well, where do I get this information for these? NGWA Bookstore has a lot of materials. Your insurance company, Loss Controls Division, usually has a lot of materials for presentation, and or we'll send out presenters for you. Federal Motor Carrier and OSHA have regulations and programs for safety. Loss control evaluation. If you do have a loss, try to determine what and where and how that happened and evaluate it. And then the same way with the accident, evaluate what you can do to make this better and not happen again. We had a guy putting the stabilizer on the top of our tanker, and he slipped and hurt his back. Well, he got his back straightened out, and we looked at that and said, okay, this is a big stabilizer. So we took a piece of 4-inch casing and made a design of a thread protector that screwed on the end of that with that roller system and a chain on it. And 2 things can happen. Either he can get up there and pull that backwards with that roller on it, or we install a winch on the bulkhead of the truck. I can stand there with my remote control, and I can have that winch pull that stabilizer down on there and let the thing down with my winch and lay it down there without any more than the movement of that lever. That's the way to do it, guys. Safety first. We talked about that at work. We do it every day. Well, what about at home? Mom wants you to fix that. You go to the drawer and you pull out that old screwdriver, and you know that thing's going to bite you because it's all wore out. And you do it anyway. Bingo, you hurt yourself. Carry safety to home. At play, a lot of us have hobbies with high horsepower motors or snowmobiles or boats or hunting or whatever. Be sure and use that safety all the time. At the end of the day, you come home and you get done with work, and what do? You walk in the bedroom, you sit down, take your boots off, down with the pants, throw them on the floor, and you go to bed. Well, if you're my age, and my last name's Thron, I got to visit a relative occasionally during the evening. And so you get up and you walk around the corner of the bed and you trip on those boots or on those pants. The next thing you know, you lose your balance, you put a hole in the wall, you wake mama up, and everybody's in trouble. Use a little extra safety. Hang that stuff up and use a little caution there. Make safety last. Think about it. In closing, in Minnesota, I've had the opportunity to start some groundwater festivals for children. And the metro area of St. Paul, Minneapolis, come up with this quote that they put on their shirts. And think about what it says. Water affects everyone and everything on earth. We provide the second most important thing to people. The first one is air. Second one is water. We are the groundwater professionals. Flaunt it, people. If you have any questions, we can take a couple. Otherwise, we got to get out of here quite soon. The number that you're probably looking for, just 1 second, please, is RT, Richard Thron, 56DO. Say that again, sir.
The jar on it?
Yes.
How much will that lift? How much
they each have a tonnage built into the system, and so that will cover the 4-inch and 6-inch casing for, I think, 4,000 pounds or something like that. So there's a lot of manufacturers that make these casing elevators. Just determine what your weight capacity could be, build in a fudge factor, and go from there. We're out of time, folks.